with PFAS regulation on the horizon, people look to find alternatives for materials such as polytetrafluoroethylene PTFE, and one of those candidates is ultra high molecular weight polyethylene. What is this for a material? So it says already in the name, ultra high weight molecular. So it has a molecular weight between 3000 to 6000 kilogram per mole, which is compared to a high density polyethylene which has around 500 kilogram per mole, quite high. Ultra high molecular weight polyethylene has melting point of around 130 to 140 degrees C and a glass transition of minus 160, and a coefficient of friction of 0.25. And when we compare that to PTFE, PTFE has a coefficient of friction of 0.1, so this is more than double. However, when we go now in the friction and wear application areas, there are certain tests, and one of that is the sand slurry test, and there ultra high molecular weight polyethylene performs 8 times better compared to the PTFE. And another well-known test for friction and wear applications is the Tabor abrasion test, and here the loss is only 5 milligram per 1000 cycles. When you compare that to PTFE, here the value is much higher at around 500 milligrams per 1000 cycles. There you see already it's a quite good alternative for, and also safe for friction and wear applications. However, we have to be careful of the temperature levels. So it is, compared to PTFE, can be used for temperatures up to maximum 100. As I said, melting point is already 130. So here clearly PTFE outperforms in applications where high temperature demand is needed. Chemical resistance is really good with this material as well compared to PTFE. However, the temperature during your material selection you need to take care of. Here the next alternative would be, for example, polyether ketone, which has also really good friction and wear properties and also brings chemical and the high temperature resistance. And in terms of inorganic materials, we can also add some HBN, hexaboron boron nitride, as an additive, which can be then enable friction and wear properties. I hope you enjoyed this video. Let me know in the comments what you think of this alternative, and see you in the next video. Bye.